All right, so hi everyone. All right, so hi everyone. Very good evening to you all. Welcome back. Myself, Ayush Tripathi, mentor and problem setter at Geeks for Geeks, and welcome you all to this post analysis of last Biwizard monthly coding contest. So, how was your contest? Anyone? So, just allow me some time to select the problems. So, can someone just please confirm if I am audible and equally visible? Or let me just check. So can someone just please confirm if I am audible and equally? All right, so yes, everything seems good to me. All right, so let me just quickly share my screen. All right, so let me just quickly read the problem statement. So we are given a binary array, ARR of is equal to 0. Then there is a white stone present at index I. Otherwise, if ARR of I is equal to 1, then there is a black stone present at index I. And we have an infinite number of boxes of size k. All right, and we need to separate the white and black stones by putting them into different boxes. All right, and task is to report the minimum number of boxes. So let's take this example. So n is equal to 4, that is size of the array, and the elements are 0 1 0 1, that is 2 black stone and 2 white stone, and the value of k is equal to 2. So in one box you can put no more than k stones of the same time. same type, right? So what we can do, we can use two boxes. In box 1 I will put two white stone, and in box 2 I will put two black stone, right? And this is the minimum number of box that we are required. We cannot minimize this thing further. So a very straightforward problem. First I will count. First I will count. So let's say count W is equal to number of black boxes, black stones, and count W is equal to number of white stones, right? And then I will divide this count W. All right. So what I will need the total number of boxes is equal to count B, a seal value of count B plus divided by K. These many boxes we required, because at each box we can place up to K stones, plus the seal value of count W by K, right? For this first example, our answer is equal to seal value of count B is 2 by 2 plus seal value of 2 by 2, which is 1 plus 1 equal to 2, right? This is the minimum number of box that you will require. So I guess the enough discussion for the problem. Let's just quickly implement this. So CNTW, number of white stones, and CNTB, number of black stone. Then using for each loop, I'm iterating over this array, and if x is equal to 1, then that means a black stone. So CNT B plus plus. Otherwise CNTW plus plus. And my answer will be equal to seal value of and this seal function is an inbuilt function in C++, so you can use that. So seal value of CNT B by K, and make sure to convert one integer into a long, because if both the integers are of integer data type, then you will the result will store in first some integer data type, then will store in some specified variable. So first this thing will be calculated, and that result will store in some integer data type, and the floor value of this will be stored. So what you can do, you can convert this to a double, right? Now everything will work as same as the expected. Then CNTW by K, and then what I will do, I will simply return this answer. So let's just quickly run this program. We got some error. Okay, answer was not defined. Forget to declare answer. Same as the expected one. Alright, so submitted. Hi Abdul. So is the solution is clear to everyone? This solution, the time complexity the time complexity is O of n and the space complexity, auxiliary space complexity is constant. Right? We are not using any extra space to store something and we are iterating over the array exactly once said that's why time complexity is O of n and is the auxiliary space complexity is constant. And see, you might argue that what about the input array? So input array is not considered under the auxiliary space complexity. Auxiliary space complexity is the space complexity that you use to solve your problem. So let me just quickly select the second problem, which is a distribution problem. There is some network issue, I guess. Really sorry for that. All right, so another interesting problem, the distribution problem. So there are n apples and m friends. The ith apple, the ith tree. So there are n apple trees and m friend. The ith apple tree has AI apples and it takes BI unit of energy to plug one apple from this tree. And screen not show. Is my screen not visible to you? Is it visible now? Right. So there are n apple trees and m friends. The ith apple tree has AI apples, and it takes BI unit of energy to plug one apple from this tree. And the friends want to pick the maximum number of apples. Please note this thing is very important. The friends want to pick the maximum number of apples, possibly such that they can be distributed equally among themselves and find the maximum number of apples while minimizing the energy required to required to plug them. So let me explain you this with an example, or maybe this one. So for the first example, you are given a trees, four trees, and the higher tree has AI apple. First tree has five apples, then second tree has five apple, then one apple, then one apple, right? And the first tree will take 1 unit of energy to pick one to plug one apple from it. Then second tree takes 2 unit of energy to plug one apple from it, and the third tree takes 5 unit of energy to plug one apple, and the fourth tree takes again 5 unit of energy to plug one apple. So first of all, we want to maximize the number of apples. So we want to maximize the number of apples that we purchase, and this number of apple must be divisible by m. So let's say it is x. So x mod m must be equal to 0 because it was mentioned in the problem statement that we are interested to buy the maximum number of apples such that they can be equally distributed among the m friends. So we want to find the maximum value of x such that x mod m is equal to 0, where x is the number of apples, right? So a very easy thing, the value of x is equal to, so let's say total is equal to total number of apples in all the trees. So summation of I from 0 to n minus 1, a of I, right? These are the apples that we have. And how many apples, maximum number of apples that we can purchase. So we can purchase total minus, minus what? Total minus total modulus m. So this formula is very, very important. So for this example, total is equal to total number of apples 5 plus 5 plus 1 plus 1, right? So which is 20, not 20, but 12, right? These are the number of apples that are available to you. And among these apples, you want to find the maximum x for which it is divisible by m. So the maximum value is 10, and for which 10 mod 5 is equal to 0. And this is nothing but total minus total modulus m, which is 12 minus 2. 10 modulo 5 is 2. All right. So these are the number of apples that we need to, the maximum number of apples that we can purchase. So you can see here, we can ignore these amounts of apple, right? So which apple I will ignore? So we'll definitely ignore the apple with the largest cost, right? So among the total 12 apples, I can ignore two apples. So I will ignore those apples which are having the highest cost. So highest cost basically means requires more unit of energy to plug. So this apple fourth will require 5 unit of energy greater than every other apple tree out there. So I will ignore this one. Then this one also takes 5 unit of energy to plug one apple. So I will ignore these two apples, right? And will purchase 10 apples. This is the maximum number of apples that we can purchase so that it is divisible by m. I will purchase 10 apples using 5 plus 2 into 5. For the first tree, we have only we require 1 unit of energy, and we are purchasing 5 apples, all the 5 apples. So it will require 5 unit of energy. Second tree takes 2 unit of energy to plug one apple, and we are purchasing 5 apples. So 2 into 5, which is equal to 5 unit of energy. This is your answer, 10 and 15. So 10 and 15. So again, let me just quickly summarize this. So from the total, we can ignore these apples, right? We can ignore these amounts of apples that we do not purchase. So which apples is helpful to ignore? So for which the amount of energy required is largest. We'll ignore those apples. So what I can do, I can simply sort them in descending order of energies, and then we'll ignore this amount of apples. So is the statement and problem statement and solution is clear to everyone? Yes, no, anything? That what I'm trying to say and what I'm trying to achieve. Write a plus one. If the problem statement is clear to you. Yes, no, anything? Okay. So I'm not going to implement the solution from the scratch. So let me just quickly show you the implementation. As I am restricted with time as well, having some other priority task. All right, so hope that my screen is visible to you. All right, so we have to complete. Ith element denotes the apple at ith tree, number of apples at ith tree, then cost of the unit of energy required to pick one apple is denoted by the ith element for the ith tree. Then total apples that we have. Then there's a vector of pair of long, comma long. Then first I will calculate the total apples that we have in all the entries, then total energy that we require. So the total energy is required by AI, number of apples, multiplied by B of I. We have AI apples. For every apple, we require BI unit of energy. Then this pair P, and here I am inserting the pair for every tree BI, comma AI. Then I am sorting this in ascending or descending order of B of I, that is unit of energy, sorting in them in descending order, right? So we can ignore these many amounts of apples, total apples, modulo m. We can ignore these amounts of apples. So we'll ignore those apples which takes more unit of energy. Then there's another temporary variable, then energy wasted. So this will store the total number of maximum amount of energy that we can get from these number of apples. Then simply iterating from 0, while remaining apples, that is number of apples that we can ignore, is greater than 0. Then auto IT is equal to P of current is pair. Then for the current tree, the energy is this one, and how many apples are there? This one, it dot second. Then if the remaining apple is less than or equal to number of apples for the current tree, then I will select the remaining apple from this tree. So the energy wasted will be updated as remaining apple multiplied by energy, and I will mark remaining apples with 0. Otherwise, I will subtract the amount of apple for this tree and add their energy, right? And once the energy becomes 0, then this while loop will terminate. And after this, I will create a vector which is our answer vector, and the first element should be the number of apples that you have purchased and their minimum energy required. So total apples minus remainder, then total energy minus energy wasted. And the time complexity is linear, and the space complexity, okay, not linear. The time complexity is n log n, and the space complexity is constant, not constant, but a linear. So let me write it over here. Time complexity is n log n because of sorting, and the space complexity is linear because of that p vector, because of this p vector of size n. Which one? This one. So is the solution is clear to everyone? Write a +1 so that we can discuss the next solution. Yes, no, anything? This is so good. Yes, very interesting problem. So let me just quickly open the last problem. And this problem is another easy problem, I can say. The best thing about this problem, you have to figure out the constraint. Are very, very small. So let me just quickly share my screen. So you are driving a car on the x-axis, x coordinate, but unfortunately you run out of fuel, and exactly at point X. We are at point X, and luckily there are refueling stations. For any non-negative integer k, there is a refueling station at point 2 power k, and we need to find the position of the nearest refueling station. And if there are more than one possible stations which is nearest to the coordinate x, then you have to return the one with which is on the right side. So for x is equal to 3, the nearest station is at coordinate 2 and 4. And since 4 is the rightmost one, so we return 4 as our answer. So let's see how we can solve this problem. So you are given an integer x, right? Integer x will be given to you. So integer x will be given to you, and you need to report the closest value of 2 power k, where k is some integer greater than or equal to 0. So for x is equal to what I can say, a 3. So let's say x is equal to 3. So on a number line, 3 will be somewhere right here, and the nearest refueling station is at 2 and 4. So 2 is nothing but 2 power 1. Value of k is 1. then 4 is 2 power 2. Value of k is equal to 2 here, and value of k is equal to 1 here. So both the stations are at the same distance, so we need to report one which is in the right side. So hope the problem statement is clear to you. And the best thing about this problem is to analyze the constraint. So what I can do, I can simply iterate over this refueling systems. So the refueling systems are at coordinate 1, right, which is 2 power 0, then at coordinate 2, then 4, and then 8, 16, 32, and so on so far, right? So that is 2 power 1, then 2 power 2, 2 power 3, 2 power 4, 2 power 5, and so on so far. And the maximum value of x can be up to 10 power 9, right? So what we can do, we can iterate to 10 power, let's say 10 power 12 to be on the safer side. So we iterate up to 10 power 12, right? While this integer is not become around 10 power 12, we'll keep on multiplying it by 2. And for every refueling tank, I will calculate the distance from x, right? So that is, so let's say this is current, so x minus current, and we'll keep track of the closest refueling tank. So this was the entire explanation, and the number of steps to require to reach 10 power 12 is log of 10 power 12, because we are multiplying the previous coordinate by 2 every time, from 1 to 2 to 4, then 4 to 8, 8 to 6, 16, then 16 to 32, then 64. So to reach 10 power 12, it will take log of 10 power 12 base 2, which is nothing but 12 multiplied by log 10 base 2, which is somewhere around, let's say, 4. So it is around 48. In just 48 steps, you can reach to 10 power 12, which is a very, very small number. So let me show you the implementation. So initializing answer at -1, then B, the current coordinate, refueling tank, then iterating to 10 power 12. 1e12 basically means 10 power 12. Then calculating the distance from coordinate x. So here x is given as integer a, calculating the distance, and if it is less than or equal to the distance that I have encountered so far. So the encountered distance so far is some bigger values, and because we are interested in the smallest distance. So, and if it is less than or equal to, and why I am writing equal to, because for equal to we are interested in the coordinate which is on the right side. So then I will update answer as this current coordinate, which is b, and update the minimum closest distance that I have encountered so far. And every time I will multiply b by 2. And after this while loop, I will simply return answer. So is the problem statement clear to everyone? Accepted. Write a +1 if this solution is clear to you. Can we use just logarithmic? Can we use just logarithmic? Yes, the time complexity is this one. This is the time complexity. Log 10 power 12 base 2. Clear to you? Write a +1 if the problem statement and solution is clear to you, so that we can wrap the session. Or let me know if there is any doubt. So I guess we are good to wrap the session. Thank you so much, guys, for joining the session. Have a good day.